So in this question, I've got two independent variables. I've got x and y, and they've got PDFs that are a little bit similar. The probability x equals x is 1 over 7 for all natural numbers of x from 1 to 7. And probability y equals y is the reciprocal of y, and y can only be 2, 3 or 6. We want to find the probability that x is greater than y. So first of all, I'm going to draw a sample space of what's going on with these two PDFs. So I've got my x and my probability of x equals x, and my numbers from 1 to 7 all listed out. Now they've all got an equal chance of being selected, so they're all 1 over 7. So if I add all these numbers up, I've got 7 numbers which are all 1/7, so obviously the sum of those is going to be 1. So that's fine. Now for y, let's just check y. Probability y equals y. I can only have 2, 3 or 6. And then I've got 1 over y. So whatever y is, it's its reciprocal. So I've got a half plus a third plus a sixth. So if I change them all over 6, I've got 3 over 6, 2 over 6, and 1 over 6. And we can see clearly that adds up to 1. So these two are valid PDFs. So that's all good. But now we want to find out the answer to this question. Probability x is greater than y. So we've got 3 cases of y. So let's work out what happens with their comparison with x. So let's work out the first case. So case 1, probability y equals 2. Now x, in that case, if x is greater than y, x has to be 3, 4, 5, 6, 7. So there, that one goes with the probability x is greater than 2. So what we need to work out what we have here, we want the probability that y equals 2 and x is greater than 2. So for that, what have we got? We've got 1, 2, 3, 4, 5 opportunities of x. So we've got 5/7. So we add those all up. And then the probability that y equals 2 is just simply 1/2. So that's the probability y equals 2 and x is greater than 2. Now the next one is for y is 3. That's our next case. So in this case, probability y equals 3, in which case we need the probability that x is greater than 3. So then let's write out our probability. So we want the probability y equals 3 and x is greater than 3. So then that would equal, well, let's pick the x is greater than 3. We've got 1, 2, 3, 4 cases. And the probability y equals 3 is 1/3. So that's our combined cases. And then the third case is when y equals 6. So then we want the probability y equals 6, and we want the probability that x is greater than 6. So probability y equals 6 is 1/6. Probability x is greater than 6 is only one chance, so it's 1/7. So let's write out our probability. So probability y equals 6 and x is greater than 6. So then we've got 1 over 7 times 1 over 6. So therefore, to work out this probability, if I just write it along here, probability x is greater than y equals the sum of these 3 probabilities. So let's just write them out. So y equals 2, x is greater than 2, plus the probability y equals 3, x is greater than 3, plus the probability y equals 6 and x is greater than 6. So if I just draw a line there just to keep those separate. So now we need to add all these probabilities up. So 5/7 times 1/2, that's going to give me 5 out of 14. This one here, 4 over 21. And this one here, 1 over 42. So now we need to add all of those up. So we need 5 over 14 plus 4 over 21 plus 1 over 42. Let's just write that a little bit clearer. Okay, now we could do this, just get a common denominator, and then we can just go straight adding them up. So put that over 42, I need 15. To put that over 42, I need 8. And that is already over 42, so that's 1 over 42. So then I've got 15, 23, 24 over 42. Now, can I simplify that off? Well, they'll all divide by 2. So, and they will all divide by 3 as well. So let's go straight in dividing by 3. So then I've got 8 over 14, which I can now go again, split them in half, it's all divided by 2, so it's 4 over 7. So then the answer to my question here is 4 over 7. And that is the answer to this question. Okay.